Hello everyone, welcome to Biology Tutorials. In this video, we're going to solve problems from Yunus A. Sinjo and John A. Simbala. Chapter 3, Total Hydrostatic Force on Surfaces. So we're given here in the problem, consider a 200 feet high by 1,200 feet wide dam filled to a capacity. Determine A. The hydrostatic force on the dam and B. The force per unit area of the dam near the top and near the bottom. So, a dam is filled to a capacity and the total hydrostatic force on the dam and the pressures at the top and the bottom are to be determined. So, our assumptions would be that the atmospheric pressure is acting on both sides of the dam and thus it can be ignored in calculations for convenience. So, we need to take the density of water as 62.2 pound mass per cubic feet and the average pressure on a surface in a pressure at the centered midpoint of the surface and is determined to be, this is the midpoint, as determined to be P average or the average pressure is equal to the density multiplied by acceleration due to gravity and the height hc. We are given with density which is 62.4 pound mass per cubic feet, the acceleration due to gravity 32.2 feet per second square or square second multiplied by our height hc which is 200 over 2 feet. And by converting pound mass into pound force, we need to multiply it by 1 pound force over 32.2 pound mass feet per second square. And again, by plugging it into our calculator, we get 6,240 pound force per square feet. Then, the resultant hydrostatic force acting on the dam becomes the resultant force is equal to the average pressure multiplied by our area. Since we already get the average pressure, which is 62.4 pound mass per cubic feet or 6,240 pound force per square feet multiplied by our area, which is 200 feet by 1 multiplied by 1,200 feet. And plugging it into our calculator, we get 1.50 times 10 raised to 9 pound force. And since we need to determine the force per unit area of the dam near the top and near the bottom, so the pressure at the top would be 0 and the pressure at the bottom, which is given by the density multiplied by gravity and the height at the bottom. Since density 62.4 pound mass per cubic feet multiplied by our acceleration due to gravity, which is 32.2 feet per second square, multiplied by our height at the bottom, which is 200 feet. And again, by converting in a pound mass to pound force, we need to multiply it by 1 pound force over 32.2 pound mass feet per second square. And using our calculator, we get 12,480 pound force per square feet. And that's it. Thank you for watching. I hope you liked the video. Bye-bye.